Hello, Algebra 2 students. Back again today to learn about inverses. This week we're going to learn how to find the inverse from a table, from a graph, and from an equation. That little funny looking symbol you see there with f and the -1 and x means inverse, and you read it inverse of f of x or f to the inverse or f inverse of x. So when you see that little -1, it just means inverse. There we go. I lost the next button. Okay, when you find the inverse from a table, it's really easy. All you do is switch the x and the y. So if we take this first table on the left and we wanted to make the inverse, we would just simply switch the x and the y. That's all you do. So if this is the original and we want to make the inverse, we just switch it. So this point, instead of -1, 4 would be 4, -1. And this point would be, instead of 0, 3, 3, 0. Instead of 1, 2, we would have 2, 1. And 1, 2, and then 0, 3, and then -1, 4. So what we did, these x's in the original function are now the y's in the inverse. These y's in the original function are the x's in the inverse. So if you have a table and you're asked to find the inverse, all you do, switch the x's and y's. That's it. Don't change any signs. Just switch the x and the y's. Okay, for a graph, same process. We're going to switch the x's and y's. So we're going to take each one of these points and we're going to switch the x and the y, and we're going to make a new graph. The new graph will be the inverse of the original graph. Okay, so let's take these points. We have 3, 1. So that's going to be 1, 3. And we have 2, 3 that I just made up. So this one would be 3, 2. 1, 2, 3, 1, 2. And then we have this one that's 4, 4. What happens if we switch 4, 4? If we switch 4, 4, it's still 4, 4, right? I missed. Right? If we have 2, 5, 2, if we switch, it's going to be 2, 1, 2, 3, 4, 5. And 1.25 is going to be 1.25, 1. Right? 1.25. No, that's not right. 1.25 is a little past that. 1, right there. Now, we'll do another example in a minute. Those are a little bit hard to see, but all you do is switch the x and the y. Switch the x and the y. Now watch this. We have a line that is y equals x, right? When I have the line y equals x, that's the points 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. We could go this way. That's y equals x, right? It's your linear parent function. You spend almost all your whole Algebra 1 year. Look what happens if we connect that. Let me see how straight a line I can draw. Ooh, I don't want to do that. If we connect these very carefully, you will notice that each black point is a mirror image across that line of a purple point. Here is 3, 1. Here is 1, 3. Here is 5, 2. Did I mess that one up? 2, 5. Where's 2? Here's 2, 5 right here. So this one and this one are mirror images across that line, right? This one goes with this one. They're all, look in these itty bitty ones right here. When you graph a function and its inverse, they reflect across or over y equals x. Okay, anytime you graph a function and its inverse, it reflects across y equals x. Now, how did we graph that? All we did was switch the x and the y. Every time you do that on a graph, if you graph the function and its inverse, if you switch the x and y, make those new points, every single time y equals x is going to be the line of symmetry. It's going to go right down the middle. All right, let's keep going. Okay. Here we have some points, and we're going to connect these points in order. Then we're going to make the inverse, and we're going to connect those in order, and we're going to see what happens, and we're going to see a visual example of a function and its inverse. So with these points that are here, we're going to start with negative 5, 3, and then we're going to go to negative 2, 7, and then we're going to go to 0, negative 1, and then we're going to go to 2, 4, and we're going to go to 4, 4. I'm just getting them in the right order here. And then 4, 6, and then 5, 7. This is the order they were on the paper that I got them from. Okay, so we're going to start at negative 5, 3. And we're going to connect that to negative 2, 7. And connect that to 0, negative 1. And connect that to 2, 4. Connect that to 4, 4, 4, 6, 5, 7. Okay? That's the original function. Those are the points that are there. Now, if we make the inverse, what do we do with these points to make the inverse? We're going to switch the x's and the y's. Okay, that's very easy, very simple. Don't try to make it too hard. Switch the x and y. So this one's now going to be, whoops, hang on. 3, negative 5. And 7, negative 2. And negative 1, 0. And 4, 2. Do you see what we're doing? Just switching the x and the y. Flipping those numbers around. And then we're going to plot those points and connect them. So we're going to start with 3, negative 5. And go from there to 7, negative 2. And then to negative 1, 0. And then to 4, 2. And then to 4, 4. And then to 6, 4. And then to 7, 5. Okay, so the purple is the original and the red is the inverse. How did we make that inverse? We made that inverse by switching the x and the y. A few minutes ago, we said that every function and its inverse are reflected across the line y equals x. The line y equals x, think about that for a minute. What are we saying? Y equals x. That means whatever x is, y is the same thing, right? So the points for y equals x are 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9. We can go the other way. Negative 1, negative 1, negative 2, negative 2, because x and y are equal, right? Earlier we said that every time you graph a function and its inverse, the line y equals x is going to be the line of symmetry. Did that happen here? If I graph this y equals x, it goes right through the middle. So when we graph the purple function, actually it's not a function, is it? It has a vertical line. When we graph this purple relation or set of numbers, and then the red points are the inverse because we switched the x and y, every point is a reflection across that line y equals x. Look at this point. If you go reflected across there, there's its mirror image. This point, there's its mirror image across y equals x. These that are really close, mirror image, mirror image, mirror image, mirror image. What happened to this one that was 4, 4? What's the mirror image of 4, 4? 4, 4. So it's the same thing. Every time you graph a function and its inverse, they're reflected across the line y equals x. That, my friends, is a guaranteed test question. Absolutely 100% guaranteed. A function and its inverse are reflected across the line y equals x. All right, let's keep going. Okay, so it's really easy to find the inverse from a table. Switch to x and y. It's really easy to find the inverse from a graph. Switch to x and y. They're reflected across the line y equals x. When you find the inverse from an equation, now there are 2 steps. The first step is to switch the x and the y. Okay, that one ought to be familiar by now. But then you have to go to a second step and solve for the new y. All right, here's an example. Make this bigger so you can see it. If the original problem is y equals 3x plus 2, okay, we could also write that as f of x equals 3x plus 2, right? Because f of x and y are the same thing. The first step is switch to x and y, right? So this is the same thing as y, so it's going to change to x. This x is changed to y. And that's what I have typed right there in that second box. Switch to x and y. Now, our second step said to solve for y. So we got a switch and a solve, right? A switch and a solve. So we switch to x and y. Now we got to solve and get the new y by itself. So look at this. How do we get rid of that plus 2? I'm going to subtract 2. So if I did that over here, I got minus 2 here and a minus 2 there. So now you have x minus 2 equals 3y, right? That's what you got right here. Then how do we get, if we have 3y, how do we get y by itself? Divide by 3. Okay. Here's the thing. How do we know when we're finished? If we're finding the inverse, right? The directions would say something like this. Write the equation of the inverse. Write the equation of the inverse. That got really ugly real quick. The directions would say, write the equation of the inverse. And you would know there are 2 steps. Okay, 2 steps. Switch to x and y, then solve for y. How do we know when we're finished? How do we know when we have that inverse? What does this solve for y mean? It means get y by itself. Look right here. Y is by itself. Doesn't matter what that other side looks like. Sometimes it's going to be ugly and complicated and nasty looking. Doesn't matter. When the y is by itself, you're finished. All right, let's do another one. Oh, this is moving. This is an ordered list thing where you can move these around. Oh, it didn't move them. Okay. Here's another one. Let's make it bigger so you can see it. Okay, your directions would say, write the equation of the inverse. Write the equation of the inverse. That's going to tell you these are the 2 steps. Switch and solve. Okay, switch and solve. Switch the x and y, then get the new y by itself. Okay, y equals 2x minus 4. That's our equation. Or it might be written f of x equals 2x minus 4. Right? It doesn't matter. Switch to x and y. Notice this y became an x, this x became a y. Now, what's next? We have to solve for y. I'm missing a step. No. Here we added 4. Okay, because we're trying to get this y by itself, so we add this 4. Then how do we get rid of times 2? Divide by 2. How do we know we're finished? Because the y is by itself. Okay? So what have we learned today? We have learned if you have a table, you can find the inverse, you just switch the x and y. If you have a set of ordered pairs or points on a graph, and they tell you to find the inverse, all you're going to do is switch the x and y. When you're asked that guaranteed test question that says a function and its inverse are reflected over the line, and you're going to say y equals x. Okay? A function and its inverse are reflected over the line y equals x. Every single time it happens. Okay? Every single time. All right, let's try one more. I don't think I have another one on here. Go smaller. There we go. No, I don't. But you know what I can do is this. Okay, so let's say we had y equals x squared. And we're going to write the equation of inverse. Okay, that is so ugly. Write the equation of the inverse. Let's see if we can get fancy and go f of x equals x squared. Okay, 2 steps. Switch, solve. Okay, switch and solve. This is y, right? So switch. And then solve. How do we get with this y by itself? How do we get rid of squared? What's the opposite of squared? You're right. It's square root. So I would take the square root of this side. If I take the square root of this side, I have to take the square root of this side. And we're going to find out we have to put a plus or minus there. We'll talk about that more later. Okay. Switch and solve. Switch and solve. Switch to x and y. Solve for y. Let's try another one. Here we go. We have one is 1/3 x plus 1. Write the equation of the inverse. 2 steps. Switch, solve. Original equation, y equals 1/3 x plus 1. What's the first thing we're going to do? Switch. What are we switching? X and the y. X equals 1/3 y plus 1. Now what do we get to do? We did switch. What's after switch? Solve. So with solve, we're going to get the y by itself. How do I get rid of plus 1? So x minus 1 equals 1/3 y. Ooh, tricky, tricky. How do I get rid of times 1/3? Times 1/3, I got to divide by 1/3. When I divide by 1/3, do you remember keep, change, flip? 100 years ago, when Miss Riddell was in school, we learned dividing fractions easy as pie. Flip the second and multiply. You guys shortened it to keep, change, flip. When we divide by a fraction, we change this to multiply and we flip this over. So dividing by 1/3 is the same as multiply by 3. When we multiply this by 3, that's going to cancel out. But if I multiply this side by 3, what do I have to do to this side? Also multiply by 3. So now I have 3x minus 3 equals y. How do I know when I'm finished? How do I know when I have the inverse? When the y is by itself. That's it. Let's do another one. These are fun, right? Switch to x and y, solve for y. Let me find a good one for us to do. How are you guys liking learning remotely? Huh? I hope it's going well for you. Already did that one. Let's just make one up. Okay. So what if I have same directions, write the equation of the inverse? Write the equation of the inverse. So let's say I have an equation of f of x equals 2x plus 7. Okay. 2 steps. What are they? Switch, solve. First thing is switch. So I'm going to make this the same thing as y. This f of x. I'm going to make that x equals 2y plus 7. And then I'm going to solve for y. So I'm going to subtract the 7 and divide by 2. How do I know when I'm finished? When the y is by itself. Okay, now you can, some of you will want to change those to decimals. That's fine, as long as you change it to the right decimal. You could also write that 1/2 x minus 7 over 2. You could write it as 0.5x minus 3.5. If it's a repeating decimal, leave it as fraction. Don't just chop it off somewhere. But any one of these would be okay. How do we know we're finished? Because the y is by itself. That, my friends, is finding inverse from a graph, from a table, from an equation. See ya. Somewhere I missed one.